Here is another example similar to the ones we just saw. It says a promissory note, and as you can tell, I forgot to write the word promissory in the problem until after the fact. So a promissory note, by the way, it's a promise. So a lot of times you see these in they get offered from the government. Okay, let's read it. A promissory note will pay $50,000 at maturity in 20 years. At 4% interest compounded continuously, what is the present value? Okay, so here's what's going on. A promissory note, a lot of times, again, you see this from the government. So they will say, okay, if you give us a certain dollar amount today, we promise that after a certain amount of time, we'll give you bring this note back to us and we will give you, a set amount of money. So you know exactly how much money you're going to get at the end of that time period. So here we know we're going to get $50,000 after 20 years. So what the government's doing is they're basically taking out a loan from you. They're saying, hey, if you give us so much money today, we promise that in this case 20 years, we're going to give you $50,000 back, and obviously the 50,000 is going to be more than what you give them initially. Now, usually the interest rates are not very high because they're guaranteeing that so the economy could go up or down. They're going to owe you that money after that amount of time. So when we say at 4% interest, what is the present value? The present value means what are we going to pay for this today? What is the value of this promissory note today? So that if it was to gain 4% over 20 years, at the end of that time, it would be worth exactly 50,000. So definitely an economics sort of example, and even the language of present value you see in the econ classes and stuff. Okay, I am not an economics expert, by the way. This is pretty much the extent of my knowledge on present value. So how are we going to go about this? We can use the same formula that we've been using. We know the amount, it's in the future, but we know the amount is going to be 50,000. It's the value today. It's the initial amount. It's the principal that we're looking for. That's the present value. What are we going to pay for this now? E raised to the 0.04, that's our interest rate, times 20 years. Now it turns out this one is a little bit more straightforward to solve than the others, the previous two problems where we had to use the natural logs and stuff. Here we don't need to do any of that because we're looking for P. So e to the 0.04 times 20, we can calculate that, right? That's going to be in a calculator, and we just divide that number over. Looks like I'm showing you answers a little too soon. Okay, so maybe we'll simplify this. 0.04 times 20, let's just call that 0.8. So 50,000 equals P e to the 0.8. And I like to just keep it here. I don't like to round in the middle of a problem. So I'm just going to divide the e to the 0.8 like this, and then I'm just going to put that in my calculator exactly the way it appears. And why don't I just go ahead and do that? 50,000 divided by, there's my E button, to the 0.8, and I've got it. 22,466.45 when you round to the nearest penny. There's your present value. Now this one is kind of surprising, right? When you look at these numbers, wait a second. I'm going to pay you 22,466.45 today, and in 20 years you're going to give me 50,000. That's more than double. And it's only earning, 4%'s not very competitive, let me tell you. Well, yeah, it is going to double, over double, but 20 years is a long time. I would not want to wait 20 years to double my 22,466. That's just too long. But it's an investment. I think I could do other things with this 22,000. Anyway, There's the problem. Okay. So you're going to see a lot of this. This section is a little bit shorter. Homework's a little bit shorter. What else? So we've got some limit questions as promised that involve E. And this is just a little bit of calculus we're going to get here in this section. So we'll conclude with this. Determine the limit. And part A is the limit as x approaches infinity, e raised to the 3x. Okay, well, let's think about that. X is approaching infinity. So that number there in the exponent's getting bigger and bigger and bigger. What's happening to our function, e to the 3x? Well, if the exponent's getting bigger, then this whole thing is just getting larger and larger. This answer here is infinity. And if you need a little bit more explanation, I don't know if hopefully this will be helpful. So this is not technically mathematically correct, but it is helpful just from a logical point of view. So, think of plugging in the infinity. Right? Well, infinity is not a number. You can't plug it in, but just kind of entertain that idea. So 3 times infinity is infinity, and e to the infinity is infinity. Why would that be true? Well, remember, e is about 2.7. So 2.7, you start multiplying that by itself, right? It's going to get huge. Okay. Let's look at another one. Again, x approaches infinity. E to the negative x. Ooh. Okay. So x is getting bigger, but then we've got a more and more negative exponent on e. And this one is not nearly as straightforward as the last one. What's going to happen? What's our answer to this? Well, maybe if we break it down in a similar way, that would help. So I'm kind of showing you everything here. So, all right, we start with this. Hey, think of e to the negative x. Here's a helpful way. Think of it as 1 over e to the x, right? It's got that negative exponent. So we can make it a positive exponent if we do a 1 over. 1 over e to the x. And then plug in the infinity this way. Well, 1 over e to the infinity. All right, well, e to the infinity is infinity, but it's 1 over infinity. So we're dividing by infinity. That means the value of the whole thing is getting smaller, right? Remember, end behavior. And so this answer is 0. We are taking 1 and dividing it by very large denominators. Well, those numbers are going to be approaching 0. Okay. And I got one more for us. It's similar to the previous. How about limit as x approaches infinity, 5e to the negative 2x? So we'll throw in some more numbers there. Well, if the limit for e to the negative x is 0 as x approaches infinity, then 5e to the negative 2x, well, is the 2 or the 5 going to change the answer? No, it's still going to be 0. And I don't have any explanation for that, but right, so if e to the negative 2x, well, that's e to the negative 2 times infinity. That's still e to the negative infinity. And e to the negative infinity, think of it like this, 1 over e to the infinity. And that's headed towards 0 in exactly the same way. All right, you guys, that is 3.1.